to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Let me just turn on my preview screen to see if I'm audible or not. Okay, so I'm perfectly visible as well as equally audible. Let me just lower down the quality. Yeah, okay, fair enough. So how was the contest today to you? The first problem was type it. The second problem was shortest XY distance in a grid. The third problem was minimum time to eat all cheese. The first problem was intuitive, but only if you draw out the edge cases. The second problem was very easy. It was from a popular idea. The third problem was easy to crack, but the implementation was a bit difficult. So this was the experience from my side. But still, was the experience from you? So we would have so we would have so we would wait for the next 1 minute. After we are done with the 1 minute, then we would proceed and start with today. So we will start after 1 minute. So we have a lot of people live right now. Can you please like the video at least? Okay, so we have 15 seconds remaining to start. Now it's 10 seconds. Okay, so let's start with the very first problem. So the first problem. So we are told that in this problem we are given a string. Okay, we are given a string. Let's suppose the string only. We have A, B, C, A, B, C, and A itself. Fair enough. Now we are told that we need to start off with an empty string and we need to build up the string by using two operations. The first operation is we need to append a character at the end of the string, and this would cost us 1 point. Okay, and then we need to append the string formed to the end of the string. What do we mean by this? Suppose we have A, B, C. Then at this point, we can again add ABC, or we can just add the whole string formed up till now to the back. That is ABC and again ABC. Okay, so now let's try to evaluate the test case. What we would do is we would have ABC, ABC, and A. So we can see that this string is repeated. So we have the first operation, then we have the second one, then we have the third one. Okay, after this we would repeat again. Okay, third one, and then we would again repeat ABC with ABC again. That is fourth, and after that we need to append A at the end. So A. So the value is 5 and the number of operations we have encountered is 5. That is why the output to this is 5 itself. Hi Ankit, how are you? Okay, fair enough. So now we would try to move forward. Okay, so now we are told that we need to do the string. So now let us first try to do this. Suppose we have A, B, C, and then we have A, B, C. Okay, so if we have a string like this, then to get the minimum, what we need to do is we need to have A, B, C, and again if we have append the three character, that is this one would encounter me a cost of 3, And again, if we have A, B, C without just copying, with only using the first operation, then it would be 3 plus 3, that is 6. And that is more than the desired answer. We know this. Okay. So let's summarize everything that we have done up till now in Hindi. Okay. So हमें क्या करना है ना, हमें एक empty string से start करना है और एक desired string दिया गया है. Okay. अब क्या करना है, हमारे पास दो ही ऑपरेशन है. आइदर कोई भी कैरेक्टर लाके रख दो, वो एक ऑपरेशन में काउंट होगा, और जो स्ट्रिंग अब तक बना है उसको फिर से कॉपी करके लास्ट में रख दो. ओके, दिस इज व्हाट इट नीड. तो दो ऑपरेशन है, अब सारे स्टेप्स को मिनिमाइज करना है. ओके, सो नाउ वी सी दैट ABC and again copying ABC is much more beneficial than having the first one. So if we have an option to do the second operation, we should do it. Okay, why? Because even if we have A and A, so there are two operations we can do. Either we append the first character and then copy the first character, that would encounter me a cost of 2. And if we have the first character and then we again append the first character, this is again 2. So even if we copy one character, one prefix, then also the cost would be same. So if we have an option to go to use the second operation, then we should definitely do it. But we are told that we can do the second operation only once, cannot be done more than once. This is the position where it is mentioned. Am I clear with the problem statement or not? So I would wait for the next 1 minute or 30 seconds. Please tell me if I'm clear with the problem statement or not. Okay, what about coder's life? Coder's life, am I clear to you? So we would wait for the 40 seconds. Okay, fair enough, it is clear to you. So I don't know what are the other students. Okay, if it is clear to you, kindly reply so that I know that you all are there. Okay, so that I can just ask you and wait for you also. Okay, fair enough. So now we need to use the operation 1. अब एक ब्रह्मास्त्र है, अब उसको ध्यान से एक ही बार यूज करना है. एक ब्रह्मास्त्र है, उसको सिर्फ एक ही बार यूज करना है. We have a special ability to copy the whole string only once, so we should use it optimally. Now suppose we have a string like this, ABC, and again ABC, and again we have ABC, and again we have ABC. Now there are one option is that we would have the first 3 characters, so we would append A, we would append B, and we would append C. 3, and then we would append the next of it, that is ABC would again be reflected, ABC. Now we know ABC and ABC is again repeating, but we can use this operation only once. That is why this would encounter me a cost of 1. That is why appending all the 6 characters would have a cost of 6. That is why the total cost is 10. Now let us copy this first character and we would write here. Now in this scenario, what we can do is we would have ABC 3, and then we would again have ABC, that is again 3, and then we can copy the whole prefix, that is ABC and ABC. Now to make the whole string, we encountered a cost of 1. That is why it's 3 plus 3 plus 1, that is equals to 7. So this is a clear example that using the special ability for more length is more preferable than using it for less length. Okay, fair enough, we can do this. So okay, that is my mom replying. Good evening, mother. Okay, fair enough. Fair enough, we have this. So now this is more preferable. Okay, if this is more preferable, we need to do it for the most string. So if we want to know how much more string we need to add, and we can use this ability once. So first what we need to do is longest prefix repeated. Why longest prefix repeated? Because we know that using it for more length is more preferable. अगर ज़्यादा लेंथ के लिए longest prefix को copy करेंगे तो वो ज़्यादा preferable होगा. That is why we need to find the longest prefix that needs to be repeated for once. Fair enough? We need to do this. Now the problem arises that we need to find the longest prefix. Now if we look at the size of the length, so what are the possible ways to do that? What we can do is, suppose we have ABC, we have ABC, again we have ABC, and again we have ABC. So what we can do is, we can stand at this index and then again one index, and then we can move forward both this, okay? Suppose A same hai, so we would move forward to this, we would move forward to this, we would move forward to this. Again both are same, we moved forward to this, we would move forward to this. Now in this scenario we need to stop. Okay, we need to stop. So now we can see that if we are standing at this index, then we would have a length of 3. Now let's stand at this index. Now let's stand at this index and try to do it. Now I would just remove all this occurrence one, and then I would stand at this index. I would first take this index. Okay, this is fine. Then we would move forward and we would take this index. Yes, this is equal. So now we have 2 length. Then we would compare this and this equal. This and this are equal. This and this are equal. We would move forward. This and this is equal. So we have the length as 6. So what we can do is to find the longest prefix that is being repeated. We can stand at each index, and then we suppose the first, we would start from the first and we would stand here. Then we would move here, move here, move here. So now for each index, we are doing an operation. So for one index, we are doing an operation. So for n index, we would be doing n into n. That is, for n index, we would be doing n square operation. If we observe the length of the string, then at max it is 10 to the power 3. So 10 to the power 3 square is equals to 10 to the power 6, which is less than 10 to the power 8. So yes, we can move forward with this. Okay. So now I would quickly go to the code and I would just show you. So what we are doing is min operation, duplicate. We are first finding the size, and then we are initializing the repeated prefix length as 0. Then we are having the left as 0. So suppose we have ABC and we have ABC. I will just show you. Okay. So if L is equals to 0, okay, suppose we are standing at this position, we are standing at this position. It is 0, 1, 2, 3, 4, and 5. So now L is equals to 0, R is equals to 3. Then we would move forward with this. That is, if L is equals to R, we would move forward. At any condition, if it is not true, we would break from this condition. And if we are able to reach this particular index, that yes, see, ABC and again A and again ABC is not gonna work. We can't do it. We need to append one character. So that is why we need to see if we are reaching here only or not. That is why this condition is there, that if C is equals to R, because we shouldn't have characters in between this. And if it is ending at this point, then we are taking out the max. So this would tell me the longest repeated prefix that is true. Okay. Am I clear till this point or not? Just tell me if I'm clear till this point or not. So now suppose we have ABC, we have ABC again, and if we have AB again. Okay. Clear enough? So we know that 3 characters would be copied. So 3 characters would have the cost as 1, because appending this character would have a cost of 1. Then appending this character would be the number of character, that is 3, and that is 2. So we can say that the total number of operation is nothing but n minus x. This would be the number of operation that is left. So I can say that x plus n minus 2 into x that is x plus n minus 2x, x minus x, n minus x itself. So n minus x is there. So answer is equals to n minus x. And if we have a value, then we would so if we have something to copy, that means we would encounter a cost of 1. So we would add 1 to it. So if we have a prefix that is being repeated, we would increment the answer by 1, and at the end we would return the answer. Fair enough? Quickly give me a 1 if this thing is clear. So I would wait for the next 1 minute to see if this thing is clear or not. Just send me a quick 1 if this thing is clear. Ankit, Coders Live, quickly tell me if this thing is clear or not. And others, the names which I don't know, quickly tell me if this thing is clear or not. Badrinath, thanks a lot. So that is why I told that if you draw out the test case and you try to think at which condition I would fail, then you would be able to solve this problem. What about others? There are many live viewers at the moment. Can you please like the video if possible? Quickly like the video. So I have successfully waited for 1 minute. 10 seconds is still left. Okay, thanks a lot, Sindhu. Okay, and I have received no doubts. So I would assume that this problem is explained well, and I would move on to the next problem. Okay, let's move on to the next problem. In this problem, we are told that we are given a n cross m grid of 0, x, and y. And we need to find the minimum Manhattan distance between x and y. Okay, fair enough. What is Manhattan distance? Row index minus row y added to the row index of this one. So what do we mean by this? Suppose we have 0, 0, then we have 0, 1, then we have 0, 2, then we have 1, 0, then we have 1, 1, then we have 1, 2, then we have 2, 0, 2, 1, and 2, 2. Suppose we want to calculate the Manhattan distance between this and this. Then it would be 0 minus 1, the absolute value. This stands for absolute value. So 1 plus y minus y, that is 1. That is why the Manhattan distance between this and this is 2. Okay, am I clear with the problem statement or not? Then I would try to explain you the test case. So till I'm explaining the test case, quickly tell me if things are clear to you or not. So now if we observe x and y, then we can see that if we go this, then we would encounter a cost of 1. That is why the Manhattan distance is 1. Okay, I would wait for the next 1 minute to see if the doubts are clear or not. Quickly tell me, Sindhu, Ankit, Badrinath, and Coders Live. Quickly tell me if this question is clear to you or not. Okay, you don't need to say me yes or something. Just send me a 1. I don't want you to work hard. Just send me 1. It is enough. 1 is enough. Okay, fair enough. Okay, fair enough. Now we would proceed further. Okay, so now we can see. So before this, let us first learn the idea of breadth first search. Okay, so what is breadth first search in graph? Breadth first search is the shortest single source shortest path, SSSP. It tells us the shortest distance from here. Suppose we have a graph kind of like this. Okay, and it is related, sorry, and it is related to something like this, and then we have this, and then we have this, and this is this. So breadth first search, what it does is, suppose we have 1, we have 2, we have 3, and we have 4, we have 5, and we have 6, etc. Okay, and then we would just have a one more connection, that is this. Okay, fair enough. Now what I would do is I would have 3 as the source, and then I would calculate from the source what is the smallest distance to all other. So the algorithm is such that we would push 3 with the distance as 0. Okay, we would push 3 as the distance as 0. So from source to source, the distance is 0. Then what we would do is we would have a queue data structure. Okay, we would have a queue data structure. What is queue? Queue मतलब कोविड का लाइन जो पहले आया उसको पहले डोज मिलेगा. Q can be visualized as a line of COVID where the first alphabet coming in would be the first patient coming in would get the dosage first. So I would first insert 30. So now I would take out this 30 and I would visit all its sources. So what are the nodes I can visit from 3? That is 1, 2, and 4. So I would insert 1 with the distance plus 1. So 0 plus 1 is equals to 1. Then I would have 2 as the distance plus 1, 0 plus 1. Then I would have the distance 4 with the distance 0 plus 1, that is 4 plus 1. Fair enough? Now we would assign the distance 1, 1, and then we have 1. Now this thing is done. Next, again, we would go to 1. We would start from 1. First, we would remove it, and then we would say that from 1, what are the nodes I can visit which is not visited up till now. 2 is already decided, 3 is already decided, and we have no other nodes. So it is done. Then we would go to 2. We would first remove 2, and then we would see what are the nodes we have not visited up till now. So we have visited the node. So we have visited the node 2. 1 is visited, 3 is visited. It's done. Then we would move forward to 4. 4 is already visited. Okay, fair enough. So now we can go to 3's next neighbor, that is 5 and 6 also. So but if you observe that I can reach 3 from 1 as so there are 2 paths to reach here, this as well as this, but it is telling me the shortest distance. Okay, that is why this is the algorithm of BFS. We would quickly implement BFS. So I would quickly explain in English what we are doing. So basically we are pushing the source as the distance in 0 in the queue. Then we would take the front element and then we would visit all its neighbors and assign the distance as +1. And we would only assign distance if it is not assigned until now. And we would keep doing this until the queue is not empty. So we would quickly implement this. So what we would do is we would have queue and then we would have int and then we would name it as queue. Then queue dot push the source. Okay, push the source as 0. So source and the distance as 0. So first one is the source and next one is the distance. And then I would use something known as pair. And then I would have int and int. Okay. Now what I would do is if q is not equal to empty, q is not equal to empty, then auto tp is equals to q dot front. Okay, then q dot pop, because we would need to remove that element also. Now what we would do is we would visit the neighbors of, suppose the graph given is g of tp, g of tp dot first, because the first one is the source. If the distance of e is equals to -1, that it is not assigned, then what we would do is distance of e is equals to tp dot second plus 1, and then we would insert it to the queue. Q of q dot push e with the distance as this of e. And this would keep going on till we are moving forward. Okay, hope this BFS thing is clear. Okay, I have not initialized and all. Just quickly tell me if this thing is clear or not. This would tell me the single source shortest path. Actually, this BFS and multi-source BFS is a prerequisite here. But to make everyone on the same level, okay, I started from point zero and made you understand the basics of graphs. Okay, terminologies and all should be done by you. I'm just doing BFS and multi-source BFS so that we all would be in the same level. Quickly tell me if things are clear to you or not. Coders, Ankit, Sindhu, quickly tell me if things are clear to you or not. Okay. So no doubts coming in. So I would say that yes, the things are clear. Now, there is one more idea that is associated. Suppose we have multiple sources. Okay, suppose we have multiple sources. Suppose this is a police station. This is police station 1. This is police station 2. This is police station 3. And then there are many houses. This is H1. This is H2. This is H3. This is H4. And this is H5. Now what I want is I would have a graph kind of thing. Now what I want is I want the shortest. So what I want is I want the shortest distance from each house from any police station to any police station to any police station. I want this. Now here we can see that we have police 1, police 2 and police 3. Now the most feasible idea we can do is we can run a BFS for all the police station, and the minimum of each would be assigned. But there is a better alternative to this. The better alternative is known as multi-source BFS. Multi-source BFS technique. In multi-source BFS, what we do is the idea is the same, just we push all the police stations at once. We push all the police stations at once, and that would give me the shortest distance from each house to any police station. So if we go back to the implementation, then where we are pushing just the source, what we would do is we would use a for loop int I is equals to 0, I is less than mni plus plus, and then we would push q dot push. Okay, q dot push, and then we would keep up all the police station with the distance as 0. So just the difference between BFS and multi-source BFS is that here we would push all the sources with the distance as 0, and rest of the BFS algorithm would remain the same. Okay, just this small modification would make from single source to multi-source. Just this small modification that we would push all the sources at once. If you have one, so you can remember it generally that if you have one source, push it. If you have multiple source, push it. Fair enough. So summing up all together in Hindi is क्या करना है ना, अगर एक सोर्स है और बाकी से शॉर्टेस्ट डिस्टेंस निकालना है, so just push that source in the queue और BFS स्टार्ट कर दो. अगर बहुत सारा सोर्स है और डिस्टेंस निकालना है, वो चोर पुलिस वाला हमेशा याद रखना, और तो क्या करना है, जस्ट बिफोर स्टार्टिंग द BFS insert all the source with the distance as 0, and that is enough to do multi-source BFS. Am I clear with this idea? Okay. Just tell me quickly, I'm clear with this idea or not. Okay, fair enough. Now let's look back to the problem. Prerequisite is done as of now. So now we can see that we need to find any pair of x and y. So if we need to find any pair of x and y, then y can be anything. So what I can do is for this y, I need to find this x, this x, this x. I need to consider all the x. Same goes for this y. I need to consider this y, and this y, and this would go for all of them. So what I can do is I can take all the x as the source, and then I can calculate the minimum distance to reach all y. And then the minimum of all the distance would tell me the minimum Manhattan distance. Okay, so this thing is already explained. What we are doing is, so let us again sum up. So the pseudo code of this would be that we push the source into queue. We push the source into the queue. Next, what we do is push the source into the queue with distance is equals to 0. Then what we do is we visit neighbors with distance plus 1. Just this. Now let's see. See, here we are pushing the source. Here we are taking out the front element, then we are removing it. Then we are visiting the neighbors of that node. If the distance is not decided, we are deciding it to distance plus 1 and we are pushing it to the queue. Okay, am I clear? Praveen Pati, just quickly tell me if this thing is clear or not. Okay, and in the case of multi-source BFS, just push all the source with the distance as 0. So now if we push this x and x as the source, then we can do this. Okay, we can do this and we can see the minimum distance to reach y. So if we made all the x as the source and the minimum distance to reach any of the y. Okay, so now there is one more thing. So in this grid, suppose we have 0 0, then we have 0 1, then we have 0 2, then we have 1 0, then we have 1 1, then we have 1 2, then we have 2 1, then we have 2 2, then we have 2 3. So from here I can visit here, 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 I can visit here. I can visit in all the 4 directions. So what I can do is I can use the if statement. First I can subtract the value of y, I can add the value of y, I can subtract the value of x, I can add the value of x, I can add the value of y. Then this is minus x minus y, this is plus x and plus 2. This is what is happening. So instead of using a if statement to traverse in all the 8 directions, what can we have something like this, that 1 1, suppose this is, so x is equals to 1, y is equals to 1. So if we add 1 to y, if we add 1 to the yth part, if we add 1 and we add 0 here, then the value becomes 1 and 2. 1 and 2 we can move here. Now the second scenario, we would just do a cake. Now what we can do is we can add minus 1 to the x and y would remain the same. So now what we can do is 1 minus 1 is equals to 0 and y would remain 1. So we are moving up. So in this way, by adding and subtracting these all values, the difference to move here and there, we can use an array itself. So what we can do is we can have an array like this. Now to show you what is the meaning of this array, suppose we have a distance as, what was the 1 1. So if we have 1 1 and we add minus 1 here and we add 0 here, then the value would come to 1 minus 1 0 and this would be 1 0 1. So we can move in that direction. Then let's do the next one. So basically if we add these all consecutive values, okay, we can move in up down, left right, diagonally, diagonal up, diagonal down, these all things. Now there is one more thing. So if we are standing like this, suppose this is 0 1, this is 0 2, this is 1 1, this is 1 0 1 and 0, so 1 0 and 1 1. Suppose I am standing at this particular index, then I am not permitted to go here. I am not permitted to go here. Why? Because this is outside the boundary. Okay, this is outside the boundary. So what I would do is I would use a valid function. So I would simply check if x is less than 0 or y is less than 0. So this would just tell me that if it is outside the boundary, return 0, else return true. So is this thing is clear or not? Just tell me this thing. This idea. This idea involves fast implementation. Just quickly tell me if this thing is clear or not. Just look at the index and just add the consecutive values. We can use a if statement to move in all the 8 direction, but to move in all the 8 direction, we need to use 8 if statement. So it's better that we can use a different array where only one loop is required. Yes, a common part. Hi Avinash, how are you? Okay, so fair enough. We have waited for 50 seconds, or let's wait for 1 minute itself. So I'm receiving no doubts up till now. If you have any doubts, consider asking me. पूछोगे नहीं तो पता कैसे चलेगा? पूछो आप ना. Okay, fair enough. Now, what we would do is we can see that we would have a queue of this would be x and y, and this would be the distance. This would be the distance, and this would be x and y. So first, all the x we are treating as source. So we are pushing all the source with the distance as 0, and we are marking it as visited. We are marking it as visited and all the distance as 0. Then we are using the normal BFS multi-source BFS algorithm. We are taking out the front element and then we are moving from 0 to 8. Okay. So we are adding the values, consecutive values I told, to move in all the 8 direction. But there is a catch to it. So if we are moving in all the 4 direction, it is within the boundary and it is not visited, that its distance is not decided up till now, then we would add the distance plus 1. Whatever distance we had up till now, we would add distance plus 1. Now what is the meaning of this? I would tell you this. So if you observe, suppose we are at 0 0, then we are at 0 1, then it is 0 2, this is 1 0, this is 1 1, and this is 1 2. So this is enough. So if we have to calculate the Manhattan distance between these two, then we are having the distance as 2. But if we are going on this side or this side or this side, the difference is 1 and the Manhattan distance is only 1. So अगर diagonal जा रहे हैं ना, तो Manhattan distance 2 से बढ़ रहा है. अगर ऊपर नीचे दाएं बाएं जा रहे हैं तो Manhattan distance 1 से बढ़ रहा है. Okay, that is why if it is more than 3, so what do we mean by this? See, up till 3, this is up, down, left and right, but these all are for diagonal. So so this is just telling us that if we are moving diagonally, then add 1. Okay, and then we are marking the distance, and then if we are marking the distance, we would push it to the queue. Then we would have the answer as int max. Okay, we would have the answer as int max. And then for all y, whatever is the minimum value, we would take out, and at the end we would return it. This is the whole idea for this. Okay, now tell me if things are clear to you or not. I would just make it a little bit down. Now tell me if things are clear to you or not. If I'm not clear, just mention the line where you want to understand. I would be more than happy to explain. Avinash, Praveen, Sindhu, and coders and Ankit, tell me if this thing is clear or not. I only know the names of this. because they are prominent in the top chart. But quickly tell me if this thing is clear or not. अविनाश प्रवीण सिंधु जल्दी जल्दी बताओ भाई कोडर्स लाइफ Okay, so I'm receiving no doubts up till now. Okay, so still I would give you 1 more minute because no one has replied up till now. So we would wait for the next 1 minute. Okay, okay. Can we trace the code for this small problem? Yes, we can. Why not? So see, let's remove everything. So see, in this array, so I will just tell you this one again. Okay. So suppose we have 0, 0, suppose we have 0, 0, we have 0, 0, 1, we have 0, 2, then we have 1, 0, we have 1, 1, then we have 1, 2, then we have 2, 0, 2, 1 and 2, 2. So अगर मुझे यहाँ से यहाँ का Manhattan distance calculate करना है, what would be the Manhattan distance? 0 minus 1, 1, and this is same. So the Manhattan distance is 1. Okay. If I want to calculate the Manhattan distance from this to this, only one difference, so that Manhattan distance is 1. If we are moving this side, Manhattan distance is 1, because 1 minus 1, 0, 1, 0 minus 1, the absolute value is 1, the Manhattan distance is 1. Manhattan distance is 1. The Manhattan distance is 1 for all this scenario. Okay. Now, if we are going on this side, okay, so Manhattan distance is 1 minus 0, 1, and 1 minus 2, the absolute value is 1. So 1 plus 1, 2. Manhattan distance for this, 1 minus 0 is 1, 1 minus 0, 1, 1 plus 1 is equals to 2. Manhattan distance for this, 1 minus 2 is equals to 1, 0, 1, 1. So 1 plus 1, 2. So हमें ये पता चल रहा है कि अगर ऊपर नीचे दाएं बाएं जा रहे हैं तो मैनहट्टन डिस्टेंस 1 से बढ़ रहा है, और अगर डायगोनली जा रहे हैं तो मैनहट्टन डिस्टेंस 2 से बढ़ रहा है. Fair enough? So now if we look at this array, then the first 4, one is for moving the 4th direction, up, down. So if we are doing this for diagonal part, we are adding 1 more. Okay, so first we are adding distance 1, but if we are moving diagonally, then we are incrementing the distance by 1. Okay, so Praveen, I am clear. Okay, fair enough. Okay. Thanks a lot. So let's trace the problem. So what we can do is, here we are pushing all the sources with 0. Suppose we have, let's take a value. So suppose we have all the values. Suppose it is 0, 1. Suppose 0, 1, and we have again 0, 1 with the distance as 0. Then we have suppose 2, 1 with the distance as 0. And we are marking it as visited. Then what we are doing is, we are adding up the values for each. This is already shown. Then if we are moved, so then we are adding the distance by 1. We are adding the distance 1. If it is within the boundary and it is not up till visited, so we would add the distance by 1. And then if it is more than the diagonal, then we are adding 1 and we are marking it visited, and then we are pushing it to the source. At the end, we would go for all the y and we would have the distance itself. But why I plus 3? Because see, I would just show you. See, I plus 3. So I is greater than 3. So see, what are the index? Let us index this. 0, 1, 2, 3, 4, 5, 6, 7, 8. So I told that these all 1, 2, 3 is for moving up, down, left and right. So if I is greater than 3, that means we are moving diagonally. That is why we are incrementing distance 2. Now am I clear? Ravi, you don't need to delete messages. It's absolutely fine if you ask me questions. Okay, now let us move to the next problem. So in the next problem, we are told that we have a mice and a cheese itself. Okay, we have the mice and the cheese. So it is kind of like this. Okay, so we are told that 1, 2, 3, 5, and 6. So this is mice and this is cheese. I would just quickly write it. This is mice and this is cheese. So we are told that there is a mice at 1, 3, and 6. And we are told that there is a cheese at 2 and 4. Okay. And then what we need to find out is we need to find out all minimum time so that all the cheeses are consumed. All the cheese is consumed. Okay. We need to consume all the cheese. And one cheese can be consumed by only one mice. And one mice can only eat one cheese. ओके एक नंबर लाइन जैसा होगा. अब उसमें माइस और चीज, चूहा और उसका खाना दोनों रखा हुआ होगा. अब बोलना ये चाह रहा है कि एक चूहा सिर्फ एक ही खाना खा सकता है. ओके और नेक्स्ट थिंग क्या बोल रहा है कि हमें सारा खाना खत्म करना है. एक चूहा एक से ज्यादा खाना नहीं खा सकता. सो एंड टू मूव इन वन यूनिट we would encounter a cost of 1. So we can say that this mice can eat up this cheese and this mice can eat up this cheese. By doing this, all the cheese would be consumed and the minimum time we have encountered is 1 itself. Okay, am I clear with the question? I would wait for the next 1 minute and I should be clear with the question. Just tell me if I'm clear with the question or not. Quickly reply me with a 1 in the chat. Okay, Sindhu and others, Sindhu and Coders and Ankit, Badrinath. Quickly tell me if things are clear or not. Okay, thanks a lot, Rishikesh. Okay, things are clear. Thanks a lot, Naveen. Okay, fair enough. Now let's try to find out. So now we can see that for all the mice, so to consume, all the mice can eat up the nearest food. All the mice can eat up the nearest food. But this won't happen when we have something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now if there is a mice, if there is a food at this position, and if there is a food at this position, okay, and there is also a food at this position, okay, and there is a mice located at this point, okay, there is a mice located at this point, and there is a mice located at this point, okay, there is a mice located at this point also, and suppose one more mice is located at point 0. Okay, red are mice, yellow are this. I will just copy this. So in this scenario, this is not gone over. Why? Because for this mice, this is the nearest one. So this mice would eat up this. And for this mice, the nearest uneaten food is this. So this mice is left and this food is also left. And one mice can only eat one food. So in this scenario, this idea would fail that each mice would try to eat the nearest food. Okay, in this scenario, this would not be possible. Okay, So we can say that greedy way is failing. So we can say that greedy fails. So when greedy fails, when greedy, so we can say that now greedy is not the way. Now we can see that we need to handle all possible combination of eating food. So whenever we need to consider all possible combination, then we should think about recursion. Okay, we should think about recursion. Recursion has a very high time complexity, and the number of and the constraint is very large enough, so recursion won't be the case. So we want an optimized version of recursion. If we want an optimized version of recursion, then we need dynamic programming. This is how we come to the conclusion that this is a dynamic programming. I would again repeat the same thing in Hindi because many people have this problem that how to detect if a problem is on dynamic programming or not. फर्स्ट क्या कर रहे हैं, फर्स्ट ग्रीडी चला के देख रहे हो, ग्रीडी काम नहीं कर रहा, अब पता चला कि मुझे हर तरीके से करके देखना, हर तरीका मतलब रिकर्शन, रिकर्शन का टाइम कॉम्प्लेक्सिटी काफी ज्यादा है, वो इस पे पास नहीं होगा. सो ऑप्टिमाइज्ड रिकर्शन को क्या कहते हैं, डायनामिक प्रोग्रामिंग. तो इससे पता चलता है कि ये प्रॉब्लम डायनामिक प्रोग्रामिंग का है. इज दिस थिंग क्लियर? Just send me a quick one. Just send me a quick one if this thing is clear. Thanks a lot, Naveen. Rishikesh, Praveen, these all things. That how we are coming to the conclusion that this is the dynamic programming. Detecting a problem if it is a dynamic programming, no, that is 50% of the part to solve the problem. Once again, okay, I would just tell you once again. So in this scenario, we can see that all the red mice are there. So first we try that जो सबसे करीब होगा हर चूहा उसको खा लेगा. ओके, तो इस 5 के सबसे करीब 3 है, इस 2 के सबसे करीब 1 है, तो खा लिया इसको. बट सॉल्यूशन में क्या हुआ, ये चूहा भी बच गया, ये खाना भी बच गया, तो ये सॉल्यूशन नहीं है और ये वाला आइडिया फेल कर जाता है. अगर सामने वाला नहीं है तो दूर वाला देखते हैं, दूर वाला से दिस वुड पास बट सम अदर वुड फेल. सो दूर वाला सामने वाला दोनों काम नहीं कर रहा है. सो हमें हर तरफ देखना है, हर तरफ देखना है मतलब रिकर्शन यूज कर. रिकर्शन का क्या है कि रिकर्शन का टाइम कॉम्प्लेक्सिटी काफी ज्यादा होता है बिकॉज ऑफ ओवरलैपिंग सब प्रॉब्लम. ओके, सो ऑप्टिमाइज्ड रिकर्शन क्या है, ऑप्टिमाइज्ड रिकर्शन इज डायनामिक प्रोग्रामिंग. That is why we come to the conclusion that this is a dynamic programming. Rishikesh, am I clear? Sindhu, am I clear? What are the overlapping sub-problems here? So overlapping sub-problems, if I start showing you, then this is not feasible. Hope you understand. Okay, because the recursion tree would be very huge. This won't fit in one screen. And drawing half part of the recursion tree in one screen and half part of the other screen, you won't understand it. Okay, fair enough. We would move forward. So now, for each mice, it can eat. For each mice, it can eat the nearest on the left hand side, and it can eat the nearest on the right hand side. But there is no point in eating the food which is beyond that. So we just need to handle two cases: eat left and eat right. We go in both the scenarios and the minimum of them would be our answer. Okay, and the minimum of both would be our answer. Fair enough. So now what we do is we define a DP state as DP of I and J. So I and J would tell me for I mices and J one. Okay, fair enough. So now let's copy this. N mices and M cheese. Okay, so we would just write this condition also. N mice and M, and we need to consume all the cheese. Okay, so a single rat can move in this direction and in this direction if there is food. So we need to handle two cases only. So we would define a DP state of DP of N cross M. Okay, M cross N or N cross M, whatever be the scenario. And then we would solve for the smallest case by ourselves. So what are the things we need to do for solving a DP problem? First is to declare a state. So declare a state, I can simply declare it as DP of N cross M. Okay, M mice is to eat M food. Okay, I can do that. So state is now defined. After the state is now defined, we need to decide the base case, the smallest case that we can handle. For the smallest case we can handle, the smallest base case would be that there are food, but only one mice is there. Only one mice. So one mice is there. So we can handle this. Why? Because suppose there is food at this position. There is 2, 3, 4, and 5. And the mice is situated here. So there is no point that we need to eat this food. Okay, one mouse. One mouse is the base case. Fair enough? Now, okay, yeah, sorry, it would be mouse. Sorry. Okay, so now the state is defined, the base case is defined. Okay, so now for the intermediate case, what we can do is, either make n mouse, either make nth mice or either make n minus 1th mice. So it can be like this, that either we use all the DP of N and M can be DP of N and M, either we make use of all the mices or either we make use of one miceless. Whichever is minimum would be our answer. That won't affect our answer. Am I clear to this point? Am I clear till this point or not? Just tell me quickly that it is clear or not. Okay, things are clear. If state, base, and making the intermediate case, everything is clear, then the implementation is very easy. What we would do is we would initialize initially that the minimum time is very large. Okay, then we would initialize all the values with the maximum value, and then we would sort this. Okay, we would sort the values. Okay, then we would say that dp of 0, that is 0 mice to eat 0 food, 0 mice to eat 0 food, is the distance from 0 to 0. Okay, first mice to eat the first food. This is nothing but, I would just tell you, first mice eating first food. So if there is one mice and one food, there is no other alternative than doing the distance between. What is distance? Distance is the absolute between I and j, I minus j. Okay, fair enough. This is what is there. So distance C. I minus j. This is what is the ABS of I minus j. Then comes the part when we are using only one mouse. When we are using only one mouse, then the distance from that point to that point. So this is for one mouse. We are doing this for one mouse itself. Then the intermediate case remains the same, that either we take the maximum of that mice and then we use either the full of it or j minus 1, that is one mice less. So either we consumed all of them or one mice less, one mouse less. This is what we do, one mouse less or all the mouses. We take advantage of all the things. Okay, so now just mention the line number at which you are not able to understand. I would just start a stopwatch. Now tell me if things are clear to you or not. So क्या कर रहे हैं ना, फिर से एक बार रिवीजन करते हैं. पहले हम लोग ने निकाले डीपी प्रॉब्लम, फिर देखा ग्रीडी फेल हो रहा. ग्रीडी फेल क्यों हो रहा है? क्योंकि हमें दोनों जगह देखना है, इधर और उधर दोनों जगह देखना है, तो डीपी यूज हो रहा है. तो क्या करेंगे ना, वी वुड फर्स्ट सॉर्ट द वैल्यूज. ओके, अब इधर देखेंगे और उधर देखेंगे, फिर बेस कंडीशन डिसाइड होगा. बेस कंडीशन सबसे छोटा कंडीशन है जो खुद से सॉल्व कर पाएंगे. जस्ट रिमेंबर दिस. फिर क्या करेंगे, बेस कंडीशन, यहाँ पे बेस कंडीशन था कि सिर्फ एक ही माउस है. देन इंटरमीडिएट केस. इंटरमीडिएट क्या केस किया कि एक माउस कम यूज करके सारा खाना को कंज्यूम करना या फिर सारे को यूज करना. ओके, दिस इज द सिनेरियो. Okay, so I would wait for the next 1 minute. So this is an open forum now. You can ask me anything. So now we would have ask me anything session. You can ask me anything. Else this session would end after 1 minute. So if I receive no doubts in the next 1 minute, this is an open forum now. You can ask me any doubts, not just related to question. If I don't receive any doubts for the next 30 seconds or 1 minute, I would turn off this session and would conclude that this session is done. Yes, the solutions are posted on the site too. Else you can just take a screenshot and you can analyze it on your own. If you have any difficulties, just search the name Siddharth Hazra. The spelling of that is in the chat itself. Just search this Siddharth Hazra in the LinkedIn. Ask me your doubts and I would be more than happy to resolve it. Okay, so that's it for today. Thank you. And if you're watching the recording, consider commenting on the video so that it would just complement my hard work, it would increase my reach, and it would make me happy. Just this thing. Okay, consider liking the video and commenting on the video. Thank you, everyone.